If I try to click outside, we get assertion failed. Yeah, so we are outside of the grid there. It's no good. But we don't want assertions to be triggered when the user just clicks outside of the freaking field. That's retarded. So we want to go into game. What we want to do in here is we want to check to see if the position that we're clicking is actually inside of the field. So what we're going to do is we're going to go constant v2 mouse position is equal to this. Now we want to check to see if this mouse position is inside of the rectangle of the field. Now I don't believe recti has a function for that. We want to create a function, basically bool contains constant v2 and point. So we want to create a function that can test if a rectangle contains a point. And we'll just create the definition for that, and we're going to return. So the rectangle contains the point if, x of the point is greater than or equal to the left, x of the point is less than the right, y is greater than or equal to top, less than the bottom. If it satisfies all these conditions, then it's inside the rectangle. So we got that nice little function there. Let's go back to game.cpp. So we're going to do an if statement. If what do we got here? Field.getRect dot contains mouse position. So if the field contains that position, then call reveal click on that mouse position. So this one will only respond if we're clicking inside of the rectangle of the field. Outside, nothing happens. All right, we're getting somewhere. We're starting to get some input shits going on here. All right, so we got the reveal click down. Now we need to get the click down for placing the flag. That's the right click. Lets you toggle the flag condition of a tile. So we go into meme field and we're going to add another function here. We're going to call it on flag click. And let's create the definition of that. So what are we going to do for on flag click? Well, first off, we can basically just copy and paste this first part here because it's essentially the same. What else we can do? Oh, we can copy this part too. Now we need to have a function in the tile to be able to toggle its flagged state. So we go up, we'll go into tile here and add some more functions. So bool is, so toggle flag, and that doesn't have to be bool, but this one has to be bool, is flagged const. So this one should be void. This one should be is flagged, is revealed. Fair enough. We don't have a has bomb yet. We'll have that one later. So let's create definition, toggle flag, assert state is not equal to, assert not is revealed. There we go. So you can't toggle the flag if the thing's already been revealed. That doesn't make any goddamn sense. Why do I have a state in here? That's not good. Then, now, if state is equal to state hidden, state is equal to flagged. Otherwise, state is equal to hidden. Fairly simple, I believe. What else we got here? And let's get rid of that. Oh, wait. Yeah, save it for sure. And this one is flagged. Create definition in there. And this one will just return state is equal to state flagged. All right. Now let me just make sure that is revealed is great. State is equal to revealed. All right, good. So if not is revealed. All right. Now in on flag click, we make sure that we're not already revealed, and then we do tile dot toggle flag. And that should toggle our flag shits. Now all we need to do is trigger this motherfucker in game.cpp. So we're going to basically just copy this code here, paste it in here. We'll do an else if here. So if mouse left is pressed, we do this. Otherwise, if right is pressed, get the position, make sure it's contained on flag click, mouse position. And this one should do it for us. Build solution. Run. All right, so if I right click, oh, I got a flag there. It's kind of, okay, it's like blinking in and out of existence. Like this. Very blinky flag. So you might, perhaps you are already getting an idea of what the problem is here. Oh shit, I just left clicked on the flag and it fucking jammed up my assertion bullshits. So, abort. So left click is having some problems. Visual Studio is having some problems. What can we do to solve the left click problems? Because I don't think I can solve the Visual Studio ones. All right, so what happened was I did the left click, did on reveal click, and here we assert, okay, we do that assertion, we check the tile, we check that it's not revealed, but we don't check about its status with regard to flagging, which is a problem. So we also need to make sure if not revealed and not tile dot is flagged, then reveal. You can't reveal a tile if it's been flagged. It's not good. So you see that assertion that I added before, it alerted me to a mistake that I made later on in coding that I might have missed if I didn't have that assertion in there. Pretty fucking sweet, ain't it? So we'll add some flags here. We'll try to click on them on the left. Doesn't work. Now the blinking flag is obviously a goddamn problem. And if you want a little bit of a challenge, maybe you've already figured it out, but you might want to think on why that is a problem. But I'm going to tell you right now, so if you haven't thought of it already, too goddamn late. So, this update model, this runs every single frame. So if I'm pressing the button, if I press the left click button or the right click button, this event here will be triggered every single frame as long as my finger is still pressing that button down. So unless I can click within 16 milliseconds and release within 16 milliseconds, I'm probably going to have multiple frames where this toggle is going to be called. It's going to be toggling on and off very fast. And when I release, I'm going to have a random chance of having the flag stay or having it be off. So what we need is a way of not just detecting every frame whether the mouse button is being pressed or not, but we want to detect the event of when it actually gets pressed. We don't want to check it every frame to see if it's being depressed. We want the event of the actual click. And there is a thing to do that already built into the framework. So we can go into Chilipedia, we can search mouse, and we'll click on this link here. So here's the documentation for the mouse class, and here's an example of using event processing. So what happens is every time an event happens, Windows will notify the application of that event. Like a mouse moves, the button was pressed, button was released, and those events are stored in the framework. They're stored in a queue, and you can then pull those events out of the queue. So what you do is you do a loop, and you call mouse is empty to check to see if there are any events waiting to be processed. And so if it's not empty, then you read an event out of the queue, a mouse event. You check the type of the event, and you handle the event. And this is how we're going to do our shits in our game here. So instead of doing windows.mouse.right is pressed, we are going to, well, let's leave this shit here for now. And let's do that loop that I just showed you. So while windows.mouse.is empty. So while it is not empty, while there are events to be processed, we're going to read an event, constant, and I'll just type auto because I'm lazy. Event E is equal to windows.mouse.read. And now we got to check to see what kind of event that is. So if e.getType is equal to mouse event type, and we're going to look for, let's do a left press first. So if the event type is a left press, Then what we want to do is let's copy this code here. Code for the left press handling. So the position, the mouse position is going to be Windows.mouse and not get position. We don't want to get the position of the current position of the mouse. We want to get the position at the time of this event. So we do e.get position. And then we just do our same shits here. We check to see if that position is inside the rectangle. And if so, we call on reveal click. Now, next, we want to check to see if the event was a right click. So we do else. If e.event is equal to mouse event, type rpress. And if so, we do the same thing here, but instead of calling on reveal, we call on flag click. And this, my friends, should enable us now to process events, single events, rather than processing once per frame. So now if I left click and hold like this and hold down, okay, I fucked it up. Obviously, if I leave, where's my game.cpp? If I leave this code in here, it's not going to be very good, right? So get rid of that, build that. Let's try to fuck up less. So now if I left click, it'll reveal one square, but if I drag it, it's not going to reveal any of the other squares because it only reveals for that click event, for the instant that I clicked. And after that, no more events are issued. And if I right click, now I get my flag here, doesn't toggle, doesn't paint the whole thing with flags. So now I can add flags all day long. If I try to left click, can't reveal that, but I can reveal other shit if I want. All right, we're getting somewhere here. Good times are happening. Now in Minesweeper, you've also got these tiles. They're not just empty tiles. The tiles that don't contain bombs, if you reveal them, they reveal the number of adjacent bombs to that tile. So we are going to have to put that into our game, obviously. Otherwise, it's going to be basically just random chance what you click on. So how do we get this shit into our game? Well, first of all, don't save. First of all, we go into meme field as usual, and we need to add an extra piece of data to our tiles here because I want to store the number of adjacent bombs. So we're going to go int n neighbor memes, not bombs, memes of course. And I'll just set that initially to -1. -1 means it's uninitialized, just a little bit of a code in there. May use that, may not. So we initialize them all initially to -1. Now we need a function or some code that is going to run through and calculate the number of neighboring memes for all these guys. So first off, let's add a public function here. Void set neighbor meme count. And it's going to be int meme count. There we go. All right. So we got a function that's going to set that neighbor meme count. And we're going to have a function. No, wait, is this the wrong? This should be in, let's get rid of that. That should be in here, right? In meme field. So let's just get that in there. Now, inside of the meme field, this was inside of tile. Inside of the meme field, use a word chili. What we're going to want to do is we're going to want to have a helper function that's going to count all of the neighbors for any given tile, all the neighbors that have bombs. So int count neighbor memes, not bombs, memes, constant v2 and grid position. All right. So this function, oh fuck, give me my light bulb. There we go. This function is going to loop. So if we pass it a position like this one, the idea is it's going to loop from here to here, loop through here. But if there's no tiles here, it's not going to loop through here. So we have to figure out the boundaries. Maximum, it'll loop through, like for example, if we pass it this position here, it's going to loop through here, here, and here. So maximum 9 tiles it's going to count. what was I saying? Oh yeah. But if the position, like if the start position is here, it's only going to count 4. It's not going to try to go here, 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 because there's no tiles there. So we need to set up the looping boundaries and then just do a loop that counts how many tiles have bombs. So first off, let's calculate the start x and the end x and the start y and the end y for our loop. Now the way we're going to do this is, well, a loop that isn't at the edge, first of all. Ideally, what we want to loop from is we want to loop from, if this is x and y, we want to loop from x minus 1, y minus 1, down to x plus 1, y plus 1. So those are our ideal ranges, but if we're at the edge of the screen, we won't be able to do that. So how does that translate into code? Well, for the x start, we want to start at x minus 1, but if x minus 1 brings us negative, then we want to start at 0. So we take the maximum of x minus 1 and 0. So we start at x minus 1, but we never go below 0. And same for y. Y minus 1 never go below 0. And the end, we want to end at x plus 1, but we never want to go above with minus 1. So we take the minimum of these two. And apparently we don't know about min and max, so we're going to go up here and we're going to include algorithm. All right, now that we have our start and our end coordinates all set up, let's put in our loop. So we set up a count variable, set it to 0. We set up our looping grid position, our 2D vector here, to 0, 0, and we loop through y to y end and x to x end. Notice here that we're doing less than or equals because we're going up until the x end, including this one. So we have to do less than or equals, increment y, increment x, get the tile at check if it has a meme, and if so, we increase the count. We return that count. So this should count our neighbor memes. So now in our constructor, I believe we want to do this in our constructor if I can frickin' find it. Here it is. So meme field. So we spawn all the bombs. Let's get rid of this reveal test. It's not important anymore. So what we're going to do is now we're going to go for, and we're going to do the same loop that we do to draw here. So I just copied this and pasted it in here. And except we're not going to draw this fucker. We're going to do tile at grid position dot set neighbor meme count is equal to count neighbor memes at grid position. There we go. Now we haven't defined set neighbor meme count yet. So we'll go into here and we're going to create definition. Yes. So what we're going to do here is we're going to do a little bit of a sanity check again. We're going to assert that neighbor, wait, fuck, I don't remember the name of the variable. What is it called? N neighbor memes, whatever. Okay. So assert that n neighbor memes is equal to -1, because the only time that you should be able to set the meme count is if it is uninitialized. So if it is -1, then we can go n neighbor memes is equal to meme count. So there we go. We set the neighbor memes. That gets initialized in the constructor here. And this should be good. Now we have a problem of we want to be able to draw our tiles. Look at, if we go into tile, draw here, if it's revealed, we just draw tile 0. But we want to draw a tile based on how many neighbor memes there are. So if there are 2, we want to draw tile 2. If there are 3, we want to draw tile 3. So how are we going to do that? Well, let's expand. Let's go to sprite codex here. Let's add another function here. So we're going to have a tile selector function, and this one is going to be much similar to these guys here. It's going to be draw tile, and I'm going to call it draw tile number, v2 for position, int n for number, and then graphics gfx. And what this one is going to do is you pass it in a number, and it will select one of these guys to draw. So we go create definition of that guy in spritecodex.cpp. And what we're going to do is we're going to switch. Well, let's promote this to a document here. So we're going to go switch n. And for example, case 0, we're going to go draw tile 0 with position and graphics, and then break. And we're going to do that for all these fuckers. So that should look something like this. Just a bit of busy work there. And then we're going to do assert n is greater than or equal to 0 and n is less than or equal to 8. So assert that is one of the values between 0 and 8 inclusive. A little bit of a sanity check there. Everything is good. Let's do that. All right, now in draw tile, we've got revealed. So instead of drawing tile 0, we're going to draw tile number. And here we've got n neighbor memes. So this will draw the correct number. Otherwise, it'll draw the bomb if it's a bomb. All right, now you can see that we are no longer revealing random tiles. And if I click, nothing. God damn it. All right, I'm sure a few of you are laughing right now, but yeah, just a quick review of the code showed me that I am indeed returning 0 from the count neighbor memes function, basically nullifying all of this work. So let's not do that. Let's return the actual result that we got, and we get our assertion failed. Bad time bears. Why do you hate me? I'm missing my window here. Let's go into debug. Call stack is right here. And let's go up the call stack. Let's see if I can find 12. Okay, 12 is not the number that I would expect you to have for sure. Draw tile. So this tile has a neighbor memes of 12. This is unacceptable. It is impossible for you to have 12 neighbors. Where have we gone astray here? All right, took all this effort to calculate X start and Y start, and then I just started the fucker at 0, 0 anyway. So that was probably not the best idea. All right, let's build this fucker and see how we get. All right, we got numbers here. We got numbers. Let's see if we can find it. Oh, there's a meme. All right, where's more memes? There's too few memes to be a good test here, but let's take a look here. So this one has 2 neighbors, and it is a 2. 2 neighbors. All right, so it looks like on first inspection, with a lot of verification here, it looks like probably the algorithm is working. We've got the numbers in here. We got the flags in here. We're getting the good shit now. All right, there's one last thing that I want to do before we call this episode, and that is I want to set a bit of a detection of when you lose, when you actually click on one of the memes. So we're going to go create a bool here. We're going to call this bool is fucked, and initially equal to false. So initially we are not fucked, but we may get fucked in the future. How is this going to work? Well, first of all, on reveal click, on flag click. So I don't want you to be able to take actions if you're fucked. So, and let's find toggle flag. No, that's not the one I want. On, where's my on shit? So the first thing we're going to do here is before we do anything, we're going to check to see if we're fucked. So if not fucked, if not is fucked. All right. Then we take our actions. So the state of being fucked basically precludes you from doing anything. And we'll do that here as well. So input is not processed if we are fucked. What else should we do here? Well, on reveal click. So we want to get fucked if we reveal a bomb. So if tile is okay, so if we reveal this bomb, then what we want to do is if tile dot has meme. Did I say bomb? Of course I didn't. I said meme. Then is fucked is equal to true. So if we reveal a meme, we're fucked. Now, that's basically all you need for the behavior. But for the when you get fucked, the way that the shit is going to be drawn is going to be different. So what I want to do is I want to add let's go toggle header code file. So in draw here, screen position, bool fucked. Hell, Lumberg fucked her. Bool fucked. And we're going to have two cases here. Two major cases. So if fucked, if not fucked, I'm getting mixed up here. If not fucked, draw like we've been drawing the whole time. Else, we are fucked. So if we are fucked, we want to draw things a little different, because when you get fucked in Minesweeper, what it does is it reveals all the bombs for you, and it also draws it shows you which bombs you drew or which bombs you flagged that weren't actually bombs. It shows you your mistakes. It shows you which bomb you clicked that triggered the end of the game. It shows you a bunch of shit. So things are different if we're fucked. If we're fucked and we're hidden, you're either going to draw the tile button or you're going to draw the bomb. So if there's a bomb at that tile, you're going to draw the bomb. You're going to reveal the bomb. So if has meme, then we're going to draw the bomb like this. Otherwise, we're going to draw the tile button. Now, for the flagged, if there's a bomb, if there's a meme, we're going to draw the bomb, the revealed bomb with a flag on top of it. And that's to indicate you did the good thing, you flagged the bomb correctly. But if there is no meme, that means you fucked up. You fucked up. You fucked up. And so we gotta indicate that. So in that case, you draw the bomb, but you draw a cross over it to indicate that there's actually no bomb there, but you thought there was one. So draw tile cross, screen position, graphics. So here's if it's flagged, we do these two things. Now, if it is revealed, what do we do here? If it's revealed and it has a meme, if it doesn't have a meme, we draw the tile number. If it has a meme, we draw the bomb red. Red indicates that this is the actual bomb that caused you to lose your shit, to get fucked. So the only bomb that is going to be revealed is the last one you revealed to trigger the end of the game. So if you're drawing a revealed square and it has a bomb, that means it must have been the one that you fucked up on. So draw it with a red background, indicating this is the one that killed you, dipshit. Now, draw here is going to pass in the is fucked boolean to tell this draw function what situation it's doing, what switch it should be executing. And that is, so if we, well, okay, there we go. I first click, but you see the one I clicked, it's got a red background, the rest of them not red. Let's try again and let's try to have a little better luck. All right, nothing here, so I can reveal all those surrounding ones. This one has no neighbors, so I can reveal all the surroundings. This one has no neighbors, no neighbors, no neighbors. Okay, so this one is a bomb. This one has one neighbor, so that means I can reveal that. I fucking don't know about this one. Let's try to put some false flags here. Let's try to reveal some shit. Okay, so here you go. You see, this has a flag. It shows you did the good thing here. These ones say you fucked up. You put flags where there were no fucking bombs, no memes, and it's all good. All right, it's time for the homework assignment. What we're gonna do I want you to do two things basically. One is instead of drawing the field at the top left-hand corner of the screen, I want you to draw it centered on the screen. You can also add a border, but that's optional. But definitely center the goddamn thing in the window. That's number one. Number two is, we've got the situation set up here now where you can lose the game. It'll enter the is fucked state, and you're fucked. But nothing happens when you win the game. There's no stopping point. So I want you to put in some stuff there to detect the game lose condition and to handle that, so you have a proper win and a proper lose state for the game. So let me just show you what that'll look like if I can get this fucker solved. This looks kind of impossible. Let's just pick one. Oh, that was good. That was a nice random one. All right, so I'm thinking 3, 2, 1. Well, if it's 1, it's got to be one of these. Maybe this guy. This guy. That satisfies you. That satisfies you. If you have to be satisfied with that, then you're satisfied. That means that's open, and that's open, and that's open. There we go. So something like this. I'm going to put this in the repo so you can have this sprite, and also put a sound in there for the lose. This is what happens when you lose, by the way. Let's just click. There you go. Yeah, nice Price is Right sound there for you. So yeah, implement that shit, and I will give you the solution in the next video. I hope you enjoyed this video. If you did, please click the like button. It helps a lot. And if you have any suggestions or questions, feel free to leave a comment or hit me up on the Discord or the forum. And I will see you soon with some more C++.